Hello friends, welcome back to my channel. In the previous video, we did discuss problems from KCET 2024 from the chapter Relations and Functions. In this video, let's continue with the same chapter, questions from 2023. Let's go with the first question. Here also in this question paper also there are 5 questions. Let's go one by one. The first question is, if f of x is equal to ax plus b, f of x is equal to ax plus b, where a and b are integers and f of minus 1 is equal to minus 5, f of 3 is equal to 3. Two conditions given and one function is given. It is a real function. They have not defined domain and range, so we'll write it as f of x is equal to ax plus b. Now the first equation here is, let's go here, f of minus 1 is equal to minus 5. So x value for this is minus 1. Let us put here x value. We are going to get the equation a of minus 1 plus b equals minus 5. Now it is minus a plus b is equal to minus 5. Let us call this as equation 1. We have one more equation here, f of 3 is equal to 3. Now put 3 in place of x in f of x. A times 3 plus b is equal to 3. So we'll get one more equation here, 3a plus b is equal to 3. Let us call this as equation 2. Now clearly equation 1 and 2 are simultaneous linear equations in A and B. Let us solve them one by one. Let us go here. Let us solve them here. First equation is minus a plus b is equal to minus 5. 3a plus b is equal to 3. Now to solve this, we have few methods. We'll go by elimination method here. To go by elimination method, let's see the coefficient of variables. Here for b in both the equation, coefficient is 1, so it is easy to eliminate b. See the sign the b has in both the equations, it is plus, so both are having positive sign, so we need to subtract equation. If one is having positive, one more is having negative, we have to add. Now while subtracting, we'll change the sign of second equation because we are subtracting first equation from second equation from first equation. Now here minus a minus 3a will get you minus 4a, plus b and minus b will get cancelled. Minus 5 minus 3, we are going to get minus 8, on both side negative sign will get cancelled. 4 1s are 4 2s are. Now clearly a value is 2. So we got a value. Let us put this a value in any one of the equations. Say in first equation, put it in equation 1. We are going to get b value, that is minus 2 plus b is equal to minus 5. This is the first equation. In the first equation, we are putting a value. So b is equal to minus 5 plus 2. So b value is minus 3. So clearly friends, a value is 2 and b value is minus 3. So our option D is the right answer for this question. Let's move on to the next one, friends. The second question is, f from R to R and g from non-negative real numbers to real numbers are defined as f of x is equal to x square, g of x is equal to root x. Which one of the following is not true? They have found the composition and at a particular value they have given the value of the composite function. Here both the composite functions are given, f of g as well as g of f. Now To solve this, we can go by this. We can find f of g of 2. By finding f of g of 2, we can verify the value is equal to 2 or not. If it is equal to 2, then it is correct statement, true statement. If it is not equal to 2, then it is wrong. That's how we can solve this option by option, A, B, C, D. The one more easiest way of solving this equation, particular question is, and if we know the domain of these composite functions, directly we can verify and directly we can will come to know which is the wrong statement given in the options. Say now two functions are there, f of g and g of f. Now what is the domain of f of g? Can you think yourself for a while? The domain of f of g is domain of g. The range of f of g is range of f. Okay. Now here, what is the domain of g? Domain of g is non-negative real numbers. And what is the range of f? Range of f, go here, range of f is R, set of all real numbers. Similarly, we can find domain of g of f and range. Domain of g of f is domain of f is set of all real numbers. What should be the range of this function or codomain of this function? That should be codomain of g or range of g, that is R here. So f of g is defined from non-negative real numbers to real numbers. G of f is defined from real number to real number. Now here, to verify this, let us go with the domain of these two functions and verify the elements which are given in the statements are present in the domain or not. Now we will go with x value here. What is x value here? 2. 2 is a real number, positive real number actually. So f of g, the domain is 0 to infinity s. This statement may be possible. Similarly, we will go with option B, g of f of 4. Here we will go with the domain of f. Domain of f is set of all real numbers. You can take positive number, negative number, any number you can take here. And you are getting a real number. This statement is also may be true. We'll go to the next one, g of f of minus 2. Again, f domain of f is a set of all real numbers, as I can choose minus 2 and value can be any real number. This statement is also true. The last one is f of g of minus 4. G function, we have to go with function g, domain is non-negative real numbers. But here x value is minus 4. X value is how much here? Minus 4. It does not belongs to domain of f of g. So it is very clear, when it is not belongs to this, then f of g of minus 4 is not defined. It cannot be equal to 4. Actually, it cannot be found. So this is how, by knowing the domain of these functions, directly we can choose option for this. So our answer is here option D, which is not true. Remaining 3 may be true. We are not verifying that because it is not defined. Directly we can pick this solution. To find this, actually how we can find? You can find f of g of 2. Here f of what is g function x, put 2 here, you will get root 2. Then put root 2 here in place of x in f of x. Then you will get here root 2 whole square, that is nothing but 2. This is how you can verify directly. Okay, here we are getting this statement is true. Similarly, this statement is also true, this statement is also true, but this statement is not defined. Okay friends, let's move on to the next one. Now again, the problem is on composition. Let f from R to R, real number to real number, defined as f of x is equal to 3x square minus 5, and g from real number to real number, again defined as g of x is equal to x divided by x square plus 1. Now let us first find g of f here. They are asking us to find g of f. Very easy question here. Easily we can find this. G of f of x is equal to, what is f of x? F of x is 3x square minus 5. Then here we'll write in place of f of x, just replace the function 3x square minus 5. Now put this value or put this function in place of x in g of x. So in place of x, if you put this function 3x square minus 5 in g, in the numerator we have x. So in place of x, we are going to get there 3x square minus 5. Wherever you have x, we are going to get 3x square minus 5. In the denominator, we have x square. In place of x, be very careful here. We have to take 3x square minus 5 in place of x. And whatever the power we have for x, that we have to put here. Square plus 1. Now this option does not exist. That let us simplify further, and to simplify further in the denominator we will go with a minus b whole square. Now it is 3x square whole square minus 2 into 3x square into 5 plus 5 square plus 1. Now clearly 3x square minus 5 whole divided by 9x to the power 4 minus 30x square. 5 square is 25 and 25 plus 1 is 26. So here option A and option C directly you can eliminate because only 3x square is there, minus 5 is not there. Clearly option B is our solution. This is how we can solve this, friends. Let's move on to the next one. This question is on relation. Let the relation R be defined in n. N means set of all natural number. That means R is defined from natural number to natural number. And relation is given like this. Relation is, you can write the given relation A related to B as set of all ordered pair A comma B such that 3A plus 2B is equal to 27. Here A and B both belongs to natural numbers. Now, which one of the following is true? Then R is. Now we have to find the relation now. Which are the elements that the relation contains? That means they have given the relation in set builder form. We are going to find it in roster form. Clearly, see, when you solve these kind of problems, the domain and codomain which they have given for the relation is very, very important. First go with the domain and codomain. Here both are set of all natural numbers. Now here option A and option D directly you can eliminate. How we can eliminate directly? See, in option A you have an ordered pair 9, 0. Here 0 is not a natural number. B also natural number. A also must be natural number. So this option you can directly eliminate. It cannot be the solution. It cannot be the relation. Similarly, go with option D. First ordered pair is 0, 27 by 2. So 0, 27 by 2 both are not natural numbers. This cannot be the solution. So left out only two options, B and C. From these two options, we will take one element each together, then we will verify, then see which option is correct. So we will go with 1, 12 first. So putting 1, 12 here, 3 into 1 plus 2 into 12, we will get 3 plus 24, that is 27. So this is true. Let us go with from option C. This is from option B. Let us go with option C. 2, 1. Clearly by looking at the values we can say it is not possible, but let us verify. 3 into 2 plus 2 into 1, it is 6 plus 2 is equal to 8, which is not equal to 27. No need to verify any other thing. So one element is not satisfying the condition, then that cannot be the set, or that cannot be the relation. So remaining option is option B, friends. So directly we can pick here option B. Friends, let's move on to the last question from this chapter in the year 23. Here two functions are given. Again, the problem is on composition. But here they have included two concepts. One is composition and one is invertible function. Now we need to find the domain of this composite function which is invertible. See, to verify it is invertible or not, first we need to find g of f of x. Let us find out g of f of x. They have given two real functions. Let us go with here. Let us find out g of f of x. What is f of x here? F of x here is sine 2x plus cos 2x. Put this value in g of x wherever you have x. Keep it in mind, the whole function we have to substitute in place of x. Now, in place of x, what we have to write then? Sine 2x plus cos 2x. So what is the power we have for x? Square. So be careful, you have to take whole square minus 1. Now it is very simple, it is in the form of a plus b whole square. We can write this as sine square 2x plus cos square 2x plus 2 sine 2x into cos 2x, and we have minus 1. Now from trigonometric identities, cos square 2x plus sine square 2x value is plus 1. So we can eliminate here plus 1 and minus 1. What is left out? 2 sine 2x into cos 2x. Using multiple angle formula, which is the multiple angle formula, sine 2x can be written as 2 sine x into cos x. Now in place of x here we have 2x. So here 2 sine 2x into cos 2x, we can write it as sine 4x. Now friends, we got composite function sine 4x. Now we need to find the domain for this function so that this function is invertible. To solve that, first we should know if you have the function sine x, in what domain this function is invertible. In the principal value branch, my closed interval minus pi by 2 to plus pi by 2, this function is invertible. The range remains same, minus 1 comma 1 closed interval. Now in this case, x belongs to this interval, that you can write it as x is greater than or equal to minus pi by 2, less than or equal to pi by 2. But the function which we have found here, sine 4x, here the angle is 4x, not x. So this angle belongs to this interval. That means here x, actually 4x belongs to closed interval minus pi by 2 to plus pi by 2. Now this can also be written as minus pi by 2 less than or equal to 4x less than or equal to pi by 2. We can write it as an inequality. Now dividing this inequality throughout by 4, we can find the value of x. Minus pi by 2 divided by 4 is minus pi by 8, less than or equal to x less than or equal to pi by 8. 4x by 4 is x. Again, pi by 2 divided by 4 is pi by 8. Now, for the given function, x belongs to minus pi by 8, plus pi by 8 closed interval. Let's see. Now, our option D is the right answer. Friends, these are the questions asked in this year 2023. If you find this explanation useful, please like, share, and subscribe. Hit the bell icon for further notification. Thank you.